Code, Cloud, IT, and silly jokes. ITT.
Hey everyone, it's Dawid Chruścielski.
And Grzegorz Kotlarz, and we are ITT. And in today's video, we are going to show you one of the cloud patterns, and it is a claim check pattern, and David will take us through that journey. So David, the scene is yours.
All right, let's change the scene there then. And let's jump into the rider, so straight into the meat. Meat, because you can see it's sender row, so row like meat. And I need to start a terminal first.
I prefer medium rare, but...
And we need to open Azure directory for myself and start Azure as a service because we are going to use locally our storage and queue, basically the storage account local emulator for Azure. And we are going to use that to exchange messages between two applications today. So we'll have application A and application B. Application A will send a message to the queue, and then application B will pick up that message. So we have 4 projects in here. Those rows are the ones that we'll start with, and then we will introduce a claim check pattern. But let's see now why we need to introduce that claim check pattern in the first place. So the code is quite simple. Let me open the sender row. Oh, that is sender row on the right side already. We can see what the code does, what the dog do, and we can check
what
that.
the dog do?
We can see that we are creating a new queue client. Super simple stuff. You use development storage account, so the local one, the Azure that I've just run. Queue name is 2 big messages. Not yet, but it will be in a moment. Just in a case, if there's no queue for us, we create it. And we send a message which is of a size of 1 kilobyte, because there's only 1 character. 1024 characters. And
yeah.
Then we send this message onto the queue. We say we've sent the message, and that's it. Okay, so let's run it. And here we can click run. Okay, and it sent this message of 1024 characters. All good. Let's just close this.
Nice grades for someone.
And then so much emotions, somebody's screaming. And let's run the receiver, but let's check what the code on the receiver side does. It's the message is already in the queue, so we don't need to do anything. It just waits there for us, so we can just, do something else in the meantime. We've got a queue client again. What do? We have a while true loop that listens for the messages, gets the messages in an interval of 1 second, and writes the message body into the console. Okay, so let's run this one. Okay, it has the message. We can see message blah, blah, blah. So it worked. All good. But there would be a problem if we would need to do something else with it. The same thing, but let's say that we want to send a bigger message. So instead of 1,000 of one batch of 1024 characters, let's say we want 128 kilobytes. That will be 128 kilobytes that will send into the queue. Will we? That's the question. So let's run. Whoa.
Oh no.
Oh no, what happened? What happened is the storage queue has a limit of message size, and we've hit that limit. The request body is too large and exceeds the maximum permissible limit. What do we do in that situation? So many people assume That's one of the questions I ask during the interviews, and many people assume that we should batch the message maybe and send the batches to the listener, and then to the receiver, and then on the receiver side we can have a state and somehow merge those messages and stuff like that. But this seems pretty advanced. This seems like a complicated logic, and a lot of stuff can go wrong with that. So in order to overcome that issue, we can introduce a claim check pattern. A claim check pattern is a pattern which is, by the way, suggested in Microsoft documentation for Storage Queue. I've checked it yesterday, actually, and they suggest to use blob storage to support bigger messages. But they do not suggest how. They do not say it is a claim check pattern. So it's a bit confusing. What do we do with this blob storage, actually? So what do we do with it? The blob storage is, for us, this data store. And message with claim check means a message with information where that message can be picked from. So our sending application and receiving application, so sender and receiver in our case, the sender drops the message content into the blob storage, then gets the information where this message is in this blob storage, and then consequently it sends the message with that information where to pick it from to the storage queue. And then on the receiving side of things, this application, the receiver, gets the message and thinks like, okay, so I have this message, I know where it is, let me download it from the blob storage, and then I can do whatever I need with it. If we send photos, if we send videos, it is a very common practice to do that, or just, big message. That's just it. It can be a big enough JSON or big enough text, as you already seen. Let's get back to Rider then.
And cook this sender to not be raw anymore.
Exactly, and cook this sender. So we can drop those two projects, actually. What we need now is the claim checked sender. So let's see how the claim checked sender behaves right now. Okay, pretty much the same. We have a message that is of size of 128 kilobytes. Then we have a blob name, because we generate the name of the, let's say, file in quotes, which will be in our blob container in Azure. And then we have blob container client, create it if it doesn't exist, and upload the blob from the memory stream with this encoding, blah, blah, blah. Quite easy. And then we use the same blob name to send it as a message. So we only send the name of the blob name. And then we say that, okay, we've sent it, press key to exit. All right, looks good. Let's just run it.
Fingers crossed.
Yeah. And now we can see it's no AAAA anymore. It's BBBAC. Yeah, it's a GUID that we sent. So that's not the content of the message. That's just the name of the blob. And now we can stop it. We can check what's happening on the receiver side. So on the receiver side, we do quite similar thing. We create a new queue client, create a blob container client, and then inside we receive the messages. Once we get the message, we get the blob client. We assume it's a simplification, but we assume that in this message, we've got the name of the container. So we simply get the message out of it and download the message, download the content of it from the blob storage. We could potentially also, because there's only one listener of this message, we could potentially also, after processing the message, delete the
blob.
The blob. Exactly. We could do that, so we will have clean state after that. And we delete the message as well at the same time. So that can be done maybe in another in another order. So then we processed the message, we cleaned the blob, all good. Let's check it out if it works.
The message is waiting.
Yeah, the message is already there.
So do we.
Mhm. Oh, quite of a message. So yeah, as you can see, the message has been received. We've managed to pass a big long message between our functions, our applications, and yeah, that's basically it. So that's how to easy overcome that obstacle that will hit in different clouds, in different message brokers. It is a very common scenario. It adds additional costs because we are using additional service to send the data. So there may be another ways of doing that, like for example in Service Bus, but it also adds the cost. But if you are using that in production, you can use the bigger tier, like the greater tier of Service Bus. Then you have support for bigger messages built in, like up to 100 megabytes as far as I remember. So there are some ways to overcome it differently without the claim check pattern, but this is a very known pattern to deal with those things. And if it comes to blob storage, for example, because we are using that, we could delete, but if we would have like a topic and we would distribute those messages into different queues, like one topic, different subscriptions on top of it, and different queues behind those subscriptions, because each application then manages its own queue and retries and dead letter queue and stuff like that. So it's a good pattern as well to do it like that. Then we don't know when to delete that blob exactly. So we can set, for example, a policy on the blob container on the storage account to delete from specific blob container after like 7 days or 2 days or whatever fits our purpose, our needs. And yeah, that's basically it. Super simple, super fast, and hopefully very useful.
Thanks a lot for showing us the claim check pattern and cooked that raw sender and receiver. Now it's very well done, I would say. And it can keep my parents satisfied because I can receive a lot of A's. They will be satisfied.
Nice one. All right, cool. That was it. Thanks for watching, and see you in the next episode. Cheers. Bye-bye.
See you. Bye.